Hey guys, I'm really sorry I'm not there. I wish I was feeling better, but I'm going to try to lead you through this lesson that I was going to have you do yesterday and just give you some notes about it. And then we can definitely review anything when I return. So, first, I have AP Stats exam scores. How did the students do on the AP Stats exam last year? Specifically, we want to estimate two things. So the two things we want to estimate, first off, we've got P. So P is the true proportion of all AP Stats students in the district who pass the AP exam. And then the second one that we want to estimate is mu. So mu is the true mean AP exam scores for all AP students, AP Stat students in this district. So what you'll notice in this unit, we're going to go back and forth between proportions and means. So first, I have a handout, but I've already taken my samples for this video, so I'm not going to go back and forth between it, but there is a handout, I think we'll use it in tomorrow's lesson, of the exam scores for all of the 253 students in a large school district. And the dot plot here shows the data in a distribution rather than on a handout, but the handout is helpful for picking our random sample. So first off, the first question, what does each dot represent? That is the AP Stats exam score for one of the students in this district, right? Remember, one dot is just one score. So then, in question 2, we want to take a random sample of 10 students and list their AP scores. So this is what I've already done. On the handout, the scores are listed from 1 to 253, and I just use a random number generator to generate 10 unique random numbers. And that's how I got the scores: 1, 5, 5, 4, 3, 4, 2, 3, 1, 5. And then I repeated it again. I got 1, 4, 1, 4, 5, 1, 5, 4, 2, 4. And finally, one last random sample, and I got 1, 5, 3, 2, 5, 5, 2, 5, 4, 4. So then the next question asks, or next part asks us to calculate two things. So first, from sample 1, what proportion passed? So to pass the AP exam, you need a 3 or higher. So we have 1, 2, 3, 4, 5, 6, 7 that passed out of the 10 total. So that's 0.70. And then what is the mean? So adding those all up and dividing by 10, I got a mean of 3.3. Now for sample 2, what proportion passed? 0.60. And the mean is 3.1. And then finally, what proportion passed for sample 3 is 0.70. And the mean was 3.6. So now we've just found proportions and means, but we're not going to label them as P and mu. So one thing I want to note up here, P and mu, these are what we call parameters. And parameters tell us about the whole population. But what we've calculated here, those come from our 3 samples. So these are instead what we call statistics, because they come from sample. So right, we can remember parameters tell us about the population and statistics tell us about the sample. So instead of P and mu, the symbols that we use, each of these are a P hat. If you remember, we had Y hat before. Now we're using P hat. And then for the means, it's X bar. I think we've talked about this before, the difference between mu and X bar. I'm not really sure we digged into P and P hat. But so those are the symbols for the statistics from a sample. And if you notice, both of them have a hat on, right? Whether it's P hat or X bar, they both have something above them. So that's one way to help you remember which symbol goes with what. The other one, the parameters, right? This is 253 students. If I were to find the average for all of them, that is from the whole population. That would be mu. If I found the average of this whole dot plot. This dot plot is what we call a population distribution. All right, so then we go ahead and we collect all of our many samples, right? We do this a lot in class. Every single group collects their own samples. We put them all on the same dot plot. For me, my sample proportions, I got 0.7, 0.6, and 0.7. And if I was there, we would do this as a class, and we might get some random assortment of data that looks something like this. This is just some data from last year that I'm going to use since we're not able to do it all together. Now this right here, what we've created now, this is what we call a sampling distribution. And it's a sampling distribution of p hat, right? We want to be specific. These are all the sample proportions. So what does one dot represent on this dot plot? Well, it's one random sample of 10 students and a proportion calculated from that sample. Right, and if you wanted to be even more specific, you could say the proportion of students that passed from that sample. All right, now I'm going to add my sample means. So I got 3.3 about here, 3.1, and 3.6. But if we were together, we would do this all as a class, and I'd have much more data that might look something like this. And again, this dot plot that I just made here, this is another sampling distribution. But this one is a sampling distribution of x bar, not p hat. So what does just one dot represent in this second one? Well, it's one random sample of 10 students and a mean score calculated for that sample. All right, so those are the main ideas for today. Just talking about the difference between population and sample. I hope you read about that a little bit yesterday. But we have both proportions and means, and then we have proportions and means for either the population, which is p and mu, or the sample, which is p hat and x bar. So let's look at the keepers for this lesson. Here they are. So our first keeper of chapter 7. So the first note that we want to see, so this is all about sampling distributions. A statistic is used to estimate a parameter. So remember, one of the big points of statistics is that we can't usually ask everybody in the population, and so that's why we pull samples. So that way we have a smaller group, easier to pull, but we let them represent or estimate for the whole population. So that's what this is saying. Statistic is used to estimate a parameter. So we have statistics to parameters. So for a proportion, the statistic is p hat and the parameter is p. For a mean, the statistic is x bar and the parameter is mu. And that's all here, these two. And then the last one, this is for standard deviation. The standard deviation of a sample is S, and the standard deviation of the population is sigma. So remember, we used to put the population in these clouds, and then the sample was a little mini cloud. So the population, those are parameters, and the sample is the statistic. And then what we created today, we made some sampling distributions, and that is the distribution of values for a statistic for all possible samples of a given size from a given population. So what we made small sampling distributions. We didn't actually make a real sampling distribution. If you remember from when we did this before, you have a population distribution, which is everybody. Sample data distribution would be just your sample. The sampling distribution should be all samples of size 10 from the given population. Of course, we are just simulating this idea of a sampling distribution. Typically, you would use technology, or you would use some type of a curve in order to show the sampling distribution for all possible samples. All right, I'm going to go back to the lesson notes now. I'm going to actually do the check your understanding for today, just to show you a little bit more practice of this content. So for each scenario, identify the population, parameter, sample, and statistic. Use correct notation for the parameter and statistic. So for part A, the Gallup organization recently interviewed a random sample of 1,013 adults in the United States and asked them how much annual income their families need to get by. The average amount for the sample was $85,000. So what I see here is they pulled a random sample of 1,013 adults. That is the sample, the 1,013 adults in the U.S. And then the statistic, again, this is about the sample, and it told us from that sample that the average was 85,000. So the correct notation or symbol for this is X bar, and it's $85,000. Now, while it might not explicitly state the population, we can tell what the population is by thinking about who the sample was pulled from. The sample is 1,013 adults in the U.S., so that means the population, because we pulled from this, is all adults in the U.S. And then the parameter, while we're not given the actual true average for all adults, we're just going to put that kind of in context. So mu is the symbol, and it's the true mean income. All right, in part D, the Gallup organization recently interviewed a random sample of 1,013 adults in the United States and asked them how much annual income their families need to get by. The standard deviation for the sample was 15,300. So again, my sample is 1,013 adults in the U.S. which means that the population is all adults in U.S. Now, the statistic, this is what was given to us. It's the standard deviation. So the symbol for that is S, and that's equal to $15,300. And then the parameter, while not given to us, the symbol would be sigma, and it's the true standard deviation of income. All right, for part C. Some curious AP statistics students believe that most cars in the school parking lot are silver. They take a random sample of 30 cars and calculate that the proportion of the sample that are silver is 0.36. All right, so what is the sample? They took a sample of 30 cars in the parking lot. So the population would be all the cars in the parking lot. Now the statistic given to us was that the proportion that was silver is 0.36. So for proportion, we use p hat. We have 0.36. And so for the parameter, this is the one that's about the population. So that's the simple P, and it would be the true proportion of all silver cars. All right. And next, the question 2. Students wanted to estimate the average word length for Beyonce's song Crazy in Love. Each student took a random sample of 5 words and calculated the mean of the sample, then used all the sample means to create a dot plot. This dot plot represented a population distribution, or part of a sampling distribution. Which one? So this one, is it part of a population distribution or a sampling distribution? So remember, the population distribution just has all of the elements in the whole population. So if we're talking about the word length for Beyonce songs, population distribution, each dot would be the word length for one word in the song. But that's not what we have here. We have a class who all took samples of 5 and calculated the mean for that sample and put them all together. So this is what we call a sampling distribution. And the reason is because each dot represents a statistic from a different random sample. All right. So that's everything for this lesson today. Hope you were able to follow along okay. Really sorry that I can't be there with you in person, but I should be back tomorrow. All right, bye guys.